We're used to science fiction. It's common to be entertained by heroes using invisible forces to do incredible things. But is this concept really far-fetched? The truth is, our world is actually saturated with invisible energy that can be harnessed and used to accomplish amazing feats that seem to come straight from the pages of a comic book. This energy can be found within the electromagnetic spectrum. The spectrum is a range of waves that are categorized by their wavelengths and frequencies. You can see from this image that on one side of the spectrum is radio waves, with a wavelength of up to 100 kilometers, while on the other side is gamma rays, with wavelengths as small as 10 to the -6 nanometers. There is an abundance of marvelous science that occurs within each of these regions, and we'll cover more of this later. But for now, let's focus on the visible spectrum. To do that, we have to zoom all the way into the small region of wavelengths that are between 700 and 400 nanometers. If you do the math, that means the human eye can only see 0.410% of the available waves in our atmosphere. At first, that might sound discouraging. If we could see more, wouldn't that make the world more colorful? Not so fast. If your range of visibility improved by a mere 0.003%, we would be able to see some X-rays and infrared. Right off the bat, our eyelids would no longer work, and sleep would be impossible, since X-rays would penetrate our eyelids. Also, all of those beautiful colors we enjoy would be drowned out by a sea of red from everything that has a temperature. Even in the dead of night, our vision of the universe would look something like this. As it turns out, our eyes are finely crafted instruments that are calibrated precisely for us to function on planet Earth. Human eyes aren't the only things that respond differently to different wavelengths of light. So does the atmosphere. And this gives rise to an important phenomenon known as the greenhouse effect. Like all waves, light from the sun carries energy across space to the Earth. Some of this energy is reflected by clouds or by the surface of the planet back into space. A bit more is absorbed by the atmosphere. The fact that the ozone layer in the stratosphere absorbs the bulk of the sun's ultraviolet radiation, which would kill plants and plankton, makes life on Earth possible. Of course, some UV rays do pass through, and they're responsible for the sunburn you get every time you stay out in the sun too long. The sunlight that gets through the atmosphere heats up everything on the Earth. Those objects, whether rocks or cars, give off electromagnetic waves in the infrared region. This means shorter wavelength rays get transformed into longer wavelengths, and that makes all the difference. While certain gases like carbon dioxide will let visible wavelengths pass, they reflect the longer infrared wavelength back toward the Earth. The more greenhouse gases like carbon dioxide in the atmosphere, the more heat gets trapped. In the end, this type of electromagnetic radiation makes a world of difference.